Hello and welcome to my channel. Today we are going to be looking at functions in C. We'll look just at a basic example of an addition function in C, just to understand functions. Basically just functions in C, nothing much. Okay, so let's head over to VS Code there. Okay, we're going to create a file. We'll name this function addition function, addition func.c. Okay, it's always imperative to name functions in a way that describes what their purpose is, so that it's easy to follow on them, it's easy to read along. So for the first part of our function, let's just include the head there, which is the standard io.h. Then let's go for our prototype. This is an addition function, so we have to identify a function with what it does specifically. The first part is the return type of the function. I would like this function to return an integer. We'll call it an int here in C. So it's int 8, then we get 8 is the identifier, then we get parameters. I want parameters to be int a and b. It will only take two parameters, just addition of some variable and another variable. Okay, so we got the prototype there. Now the entrance to the function, our main. I've always described main in a catchy way, something that I borrowed from some old C book. I usually name main as the caller of the callees being the functions that are called by main. Sometimes this definition is misleading, though, considering the fact that main also is called from the command line. So if you were to say is the caller of the callees, it would actually mean in a way that a main is never called. Main is called from the command line, but just for this purpose we call it the caller of the callees, the caller of the functions in here. Okay, so we've defined our main. We are going to store our function. We will pass it to a variable that we define as int. The return type is int, and let's name the variable to point specifically to what it does. It stores the result, so say int result, like that. We're likely to pass this one, the add function into result. So if after defining a result, after declaring result, let's define it. Result is equal to add. Let's next just give it a parameter. Let's say 10.5. Those parameters, the int a, so a is 10, and then a is 10, b is 5. Let's say this function outputs the result of the addition function. The result of the addition func is %d, new line. They always include the new line of result there. That's just how it goes. Then I just return 0, then returns an int. Okay, now the third part of the function there, let me try to save some space there so it doesn't become unnecessarily long. Now for the source code of the function, we go like this. It should be exact same way as the prototype of the function there that we defined in the beginning. They have to match, otherwise the function won't work, because this one, the function prototype, they acts as a footprint of the function that we were including in the source. Now what does this function do? The behavior of the function is very simple. It just returns the addition of parameters a and b. Okay, now what did we miss here? If anything, is always good to check. Okay, I think we're good to go. Let's compile this function and see what it does. What we get, it must compile, no problem. This one, what's the result? Let's go to the terminal there. You see the compilation is finished successfully. But then again, there is an aspect that I would like to point out of how functions can be called in C. Let's use a function pointer instead to call the result of the addition function than calling the addition function directly in main. How can we do that? We can come into main here, the entrance of the function of this program, I mean the entrance of the program. Then we define a function pointer that is this footprint here, the function prototype, and then we store that we pass that function to add, or we pass add to that pointer, I mean yeah, we pass add to the pointer, then we continue with the result. As the result doesn't change, let's do it this way. Sometimes explaining is difficult, it's better to just do it. Let's see what I'm saying here. We are defining a function pointer here of this nature. Takes the parameters int a, int b. The footprint is the same, it's just a pointer to a function here that returns int and has parameters a and b. Okay, now let's pass our pointer. Let's pass it to the pointer, because the way it is, we pass from right to left, isn't it? In C, that's what we do. So pointer equals 8, like that. Okay, now that pointer is equal to 8, we have a result here. Now instead of using 8 here, that's where the trick comes in. We can now reference 8 as pointer, because we have assigned 8 to pointer here. So we are now calling the add function indirectly using pointer here. Okay, it's like borrowing someone your identity card and then you have that person being called by your name, basically that. But you have to have the same attributes, which are the function prototypes that we saw here. We see that the footprint here is the same as the one that's here, that's just that is being pointed to at this point in time. So let's see if it compiles. It must compile, because I think it must compile. Let's check. Okay, so here goes. The function compiles successfully. This aspect of function pointers is quite crucial in C. I will demonstrate with a program that we did in ALEX of defining our own printf program. We define our own printf function, and I think that function pointers could come in handy, in that aspect, so that we pass certain functionalities of a function to a point, simply not call the function directly. I think it helps with the efficiency and stuff. I don't know about memory. I would need a demonstration on memory, on using function pointers as saving memory. I think there are some books that say so, if I'm not mistaken. Okay, for this part, I think I am done for the day. Thanks a lot for watching. Ciao. Okay, let's return. Thanks a lot for watching. Bye.